In this part tutorial, I'm going to briefly explain a bit more details about serial mediation analysis in R from scratch. So in the part 1 video, basically, I go through the basic idea how to calculate the indirect effect for the serial mediation. And we talk about the mediation model and how exactly to calculate the indirect effect. And I also lay out all the steps in the R how to do so. But actually in the R code, I realized that the step in the R code do not directly correspond very well with the stats shown on these slides. That's why I have an updated version of the steps. So that namely I'm going to talk about in this part 2 video. So the first step, basically we need to write a statistic function, namely write a function to calculate the indirect effect. That's the first step in the R code. In the second step, we are going to read the data. So this data set I simulate by myself using R. So if you are interested in how to simulate data for mediation model, you can tell me and I can make another video. But at this moment, I haven't made any video about how to do that. But you can read this data set from GitHub, and there's a link down below in this tutorial. And the third step is that you are going to use the book function to do the 5,000 times bootstrapping and then calculate 5,000 indirect effect and then calculate the complete interval. So this is part 1 video. I'm going to put a part 1 video link down below as well in case you could not find that. And so in this tutorial, I'm going to show you the actual process, namely the step 4, and also show you how can you manually calculate the complete interval. So this is the step 4 and step 5 is the focus of this part 2 video. Okay, let's switch to the R and I'm going to show you exactly the R code of these 5 steps. So remember that the first step of the R code is that we're going to write a function that to calculate the statistic of the indirect effect. So I already explained that in the part 1 video. So this is the function, the step 1. Then we read this data from the GitHub. So you can just read this data from GitHub. This is the simulated data. It's not an actual real data, but rather it's a simulated one. So you can read this from the GitHub and then just directly to the R environment. And then the step 3 is that you're going to use the book function. So and then you use this function, the statistic function we write in the step 1. And this is the data, the mediation data we read from GitHub. And this is the serial mediation function we write in the step 1, the statistic function. And then we resampling, we're bootstrapping like 5,000 times. Of course, you can change this number, but you read a lot of material online. People typically use the 5,000 times. And then you use the books.ci function to calculate the complete interval. We use the normal distribution assumption, normal distribution one, and the percentile one. Okay, so now this is I just rehearsed a bit about what I discussed in the part 1 video. Now we're going to do the step 4. We're going to show exactly, okay, remember that we do this 5,000 times bootstrapping, but what exactly this 5,000 times means? Basically, this 5,000 times is to calculate 5,000 indirect effect. You might have a question, really? Do we really have 5,000 indirect effect? Yes. So you can say, so we say this result as book mediation, yes. So, I mean, you can just run this part 1 R code in case and write a part 2 R code. So this is the data. Actually, I already run the part 3. So this equals, let me just run the part 3 again. So I set the set C 1, 2, 3. So you use the exactly same R code, you get exactly the same result as I do. So this will take a while because we are doing 5,000 times. Okay, so we just run the step 3, and so you can see the this result. And So this is the computing interval for normal distribution. This is a computing interval for percentile interval. I'm going to explain you what they means in a bit in the step 5. Okay, so let's go to step 4. That's our focus. So remember that I mentioned before that we are going to we calculated 5,000 indirect fat. You might have question, really, do we really have 5,000 indirect fat? We can actually point out this all 5,000 indirect fat actually. It goes a lot, but we can point it out. So this is the result we say from the book function. Yes, remember this book function is doing like 5,000 times bootstrapping. So we can just like copy this variable name, and then there's this output, this result we say it has a few parameter actually. So the one we are going to look is this t that we are going to print out like all these 5,000 indirect fat. So this t actually is 5,000. So we can run it. You will see that okay, it's a lot. You have 5,000. So this you can see is forever. It's like okay. It said that this reached 1,000, but there's another 4,000 rows, so it did not print out beyond 1,000 rows. So as you can see that okay, we do have 5,000 numbers. This 5,000 number actually is 5,000 indirect fat. We use the book function calculate. Okay, so then you might have a question how this 5,000 number related to the normal distribution here. So that actually the normal is that the normal is kind of assuming that the distribution of this 5,000 number is normal. So what I mean, but let me show you the histogram plot, then you have a better idea. So this histogram, basically we're going to plot this 5,000 number, yes. So remember we say this, to get this 5,000 number, where can I get that? It's based on the, there's a lot that will, so you will get based on this will be the book mediation, yes, the name we say is called book mediation, so we call it so basically, we're going to plot a histogram. So the histogram, this plot will show us the basic distribution of this 5,000 numbers. So let's see. Okay, so this you can see that this is really roughly a bell-shaped distribution, yes. So we can see that basically this 5,000 number basically follow a normal distribution. We can kind of looks like better close. Okay, so now you can see the connection between the distribution or the indirect fat and the normal distribution. And okay, after knowing this, earlier we saw that there's two ways you can calculate actually there are more than two, but we'll focus on two in this tutorial. So one is called normal distribution assumption, yes. So we call normal distribution computing interval. So the way we can calculate is that we need to calculate the bias. I'm not going to explain that what this bias means, but the way you can do that is to calculate the mean of this 5,000 number, the 5,000 number we saw earlier, and then minus the estimate just one sample. So this T0 is also indirect fat, but it's the original data. It used the data. It gives data from this data set. This data set we read from the GitHub. It doesn't do any bootstrapping, so it uses that data set calculate the indirect fat. So this T0, and so it used the 5,000 this bootstrapping minus the original one, and you calculate the bias. Actually, I have another tutorial video about the mediation analysis in R, but that's for simple mediation analysis. I explained that as well. You can go back to watch that video as well. So this bias, how we're going to use the bias? We're going to say that this T0, the original one minus bias, and as a way to calculate the indirect effect. And then we're going to consider the error in the calculation. That's typically the way we calculate the computing interval. So that's we can, and this is the first method. The second method is called percentile. So basically, it's this 5,000 number and just the percentile. Let's just run it. You will see that. So this is the first one. Okay, so this already I made mistake here. This should be 025 975. Okay, so this should be like that. Let me rerun it. So this is normal assumption, yeah, but normal distribution. So this is a 1 7 1. Let me print you again about from the book CI function. This is the book CI function. Let's print out from the book CI function so this is from the book CI function is output, yes. So then we have a better idea. So this is the book CI function, yes. This is the normal 1575 1893. So we can see that this is our menu calculation, yes. Our menu calculation, let me split into two, then we have better look more carefully. So this is the first one is from the book CI function, yes. So this is the normal, and then we did a menu calculation for the normal. The menu calculation, this is for the menu calculation for the normal, yes. So this you can see that it directly corresponds very well. So that means that we calculate correctly for the normal. And the second one is a percentile. Percentile very simple. It's just use a percentile. And we can see that the percentile, I'm not very 100% sure, even though I assume that my math, this way I write this function is correct. Let me see that. So I think so this is the yes, I think this is the correct one to write the percentile. So for the percentile, basically is that this is the 5,000 number, and then we calculate percentile. You have question about percentile, you can try Google what percentile mean, but I'm not going to explain that here. Basically, it's like it based on this distribution and cut the percentage, yes, cut the percentile, and then get the number of the 2.5% and then 97.5%, yes. So that's the basic idea about the percentile. And as you can see, that it's very close to the percentile based on this book's confident interval function, but they do not correspond directly. It's not as well as the normal. So you can see that this is 15.79, but if you write up, it will be 15.80. Another one is for upper percentile is 18.91, but this is 18.92. We can see it's very close. But they're not exactly the same. I'm not very sure why, but you have any suggestion, you can comment down below. But I believe that's the basic idea about how to calculate this percentile computer interval. Okay, thank you for watching.